Hello and welcome to this video. Today we're looking at probability versus odds. This is a video for people really in both Essential Math 40S and Applied Math 40S. You're both going to be looking at probability and odds and converting one to the other. So when we look at probability versus odds, those words in English are used almost interchangeably, but for math they're quite different for calculating. For probability, your calculation for probability is S over T. It's your basic little formula. The S is the number of successful outcomes. And then the T is the total number of outcomes. That's different from odds. Odds has a similarity to it. Odds are written with a colon as opposed to as a fraction, and it's a number, colon, and another number. The first number is the number of successful outcomes, which is the same number of successful outcomes as you would find in probability. It's the second number that causes the problem. I'll put an F for failure, although it doesn't mean failure, right? This is the number of unsuccessful outcomes. Which you can figure out by using successful outcomes and the total number of outcomes. If you have some experiment you're doing and it has 10 outcomes and 7 of those are successful, then 3 of them would be unsuccessful. So this number here would be 3. So instead of talking about it in an abstract way, let's look at a couple examples that illustrate this. In the first example, we're going to roll a 6-sided die pictured here. What is the probability of rolling a 5? Well, on a 6-sided die, your total number of outcomes is 6, because there are 6 possible things that can happen. Rolling a 5, there's one face that has a 5 on it, so you have one successful outcome out of 6. But if they ask you what are the odds in favor of rolling a 5, they're asking the same type of thing as probability, but you're going to write it differently. You have one successful outcome of rolling a 5. However, you don't put a 6 here for total outcomes. You put the number of unsuccessful outcomes. So the unsuccessful outcomes would be rolling a 1, a 2, a 3, a 4, or a 6, which is 5 unsuccessful outcomes. Notice that if you take 6 total outcomes and you take the one good one away from it, you end up with 5 bad outcomes. And that's how these are related. The one thing you want to watch out for is if they say, what are the odds against rolling a 5? Odds against means put the bad outcomes first. So this would be 5 unsuccessful outcomes where you don't roll a 5 to 1 outcome where you do roll a 5. Odds in favor and odds against are always opposites, so you're going to use the same numbers just in a different order. Example 2, let's do this the other way around. The odds in favor of Gord going to McDonald's for dinner tonight are 5 to 2. Gord is the person talking right now. For A, determine the probability that Gord goes to McDonald's for dinner. Well, we have 5 outcomes, 5 successful outcomes where I'm going to go for dinner at McDonald's and 2 outcomes where I am not. So to do A, the total number of outcomes would be 7. It's the 5 good outcomes plus the 2 bad outcomes of not going to McDonald's. I want to determine the probability that I do in fact go to McDonald's for dinner, so the top number would be my successful outcomes, which would be 5. This same 5 from here. And then for B, determine the probability that I don't go to McDonald's for dinner. Well, there's still 7 outcomes, but 2 of them are bad, meaning I don't go to McDonald's for dinner, so I put the 2 on top of my probability fraction in that case. You should be comfortable, and there's lots of examples in your book of writing probability and odds and converting them from one to another. I hope this video helps you with that process. Thanks for watching.